Thank you, Christoph. Let me begin by thanking Primetals for their kind invitation and also for this excellent organization. So obviously, the carbonization of steelmaking, the challenge we have in hand is an unprecedented one. It's a massive challenge and we cannot do this alone. Maybe not only for us, but for the whole value chain. Decarbonization, we need to come together, we need to communicate much more closely, and we need to find ways of doing this together. And I think events as such, this Primetals event, is serving greatly towards this purpose. So today I will be talking about megatrends. This is a popular topic which gained popularity, especially after the outbreak of the COVID pandemics. And we studied, I mean by we, as World Steel Association, we looked into this topic in 2020. So I'll share with you some of our main findings coming from those days. It's a vast topic, so I'll try to focus on just two areas in interest of time. After starting with an overview of megatrends, and then look very briefly to the imbalances that they brought about in the global economic and geopolitical system, and then also mention very briefly that all major economies seems to have acknowledged these imbalances and they are trying to put together a new vision for their countries. And then I'll move on to the steel industry related sections, how megatrends are expected to build a new future in terms of the global steel demand, how they are expected to shape the future of global steel demand and the future of global steel production structure. And I'd like to conclude with several very brief remarks. So let's start megatrends. First of all, do we call every trend we see a megatrend? That's not the case, of course. In order to call a trend a megatrend, first of all, it should be a long-lasting one. So there is no clear criteria, but it should last at least for several decades, right? And secondly, these are slow but powerful trends. So they don't really make a big change in our lives, in the way we work, in the way our businesses function, let's say over a year, but over decades, they make massive changes. They make dramatic changes in the way we operate, in the way our businesses function, basically in the global geopolitical and macroeconomic landscape. And when we decided to study this topic in 2020, in order to structure the study, we categorized megatrends very broadly into these 5 categories you now see on this slide. So starting from the right-hand side, the very well-known demographic and social changes, for example, population growth, aging, but also very importantly nowadays and also for the future, changing preferences. The new generations show quite different preferences and tastes when compared with the previous generations. So a departure, let's say, in our preferences, in the way we would like to work and live. And then continuing in the clockwise direction, urbanization, it doesn't really require explanation, right? It was the main transformative force of the 20th century, and it still is for the developing part of the world. Climate change and environment, yes. So this is probably one of the 2 transformative forces of the 21st century. Together with the technological progress megatrend. And lastly, maybe nowadays this is also a bit popular when compared to the others, global economic and geopolitical shifts. The world has operated according to a kind of set of principles, the neoliberal kind of, economic approach, globalization, a unipolar kind of world, but we just saw in a decade or two all of these principles changing, being challenged, right? A move from a hyper-globalization, now a retreat, and maybe towards a fragmentation of the global economic system in some areas, of course, not in all areas, and towards what we call regionalization of global economy. Again, maybe more in some areas than some others. yeah, the geopolitical system, we are all aware of the shifts, and these are, maybe the reflection of one major trend, and that's some major developing economies, as they developed their economic capabilities, technological capabilities, military capabilities, they have started, reaching the top level and started challenging the established order, let me say. So now the move from a unipolar world towards a multipolar world. So these are the megatrends. This is the way we categorize megatrends, and how we briefly explain them. So moving on, these megatrends, as I try to explain, have put quite big pressures on the global order, established order, and we now see some great imbalances. Climate change, environmental degradation, in many fronts, we've reached quite critical levels, and maybe in some fronts, irreversible levels. Economically, imbalances brought about by the hyper-globalization era, great income inequality imbalances in many countries, and resulting great political divide. So in many countries now, some people are feeling left behind, while some other part of the society have thrived during globalization. A part of the society is feeling left behind, and that's why there is this great political divide. So in some sense, the social pact is now in imbalance, is unbalanced. Well, we see all major economies announcing new economic development paradigms. So certainly the economic development paradigms for the last 2-3 decades, globalization, certain principles don't work, don't function anymore. So almost all major economies now trying to find a new economic development paradigms. So in Europe, we see the Draghi report. In US, we see the infrastructure bill, the IRA, different approaches. In China, we are all very well aware of the problems and the country trying to move to a new economic development paradigm. Technological revolution, no need to speak a lot on this. There are many people in the audience that are much more knowledgeable than me, but okay, AI especially, and the digitalization of the whole flows, let's say, all material flows. So if we can achieve that stage, then imagine the calculations and the connectedness of different parts of the value chain. So what kind of efficiencies will be discovered and will be introduced. Shifting geopolitical landscape, we've already mentioned this, and shifting individual preferences in habits and social norms. So there is some great imbalances in the current order. Actually, we are already seeing steps towards changing, right? So these imbalances have to be resolved. That's what we are faced with. And yes, almost all major economies have acknowledged this. They say that, yes, we are seeing these great imbalances and we want to put together a new vision. And this new vision in Europe, in US, in China, maybe can be summarized with 2 words. We want to be sustainable, environmentally sustainable. So this is our new vision, but not only environmentally. We want to be socially sustainable because we are seeing that our social pact is not in this harmony anymore. So we need to fix that. Economically, we need to be sustainable. We need to move to a new economic development model which puts us on a sustainable track. But not only sustainability, resilience. Almost all major economies now acknowledge that, look, we are in a transition stage. We see great imbalances. We see great uncertainties. We see increasing volatility. So we need to make sure that our countries are resilient against these great uncertainties, great volatilities we are seeing in the world today. So we need to be resilient. So we cannot be, shake greatly at each volatility or whenever a new event, kind of shock pops up. Okay, so this was the introduction part, and let's now try to look into the impact of megatrends on global steel demand. So this chart shows a long-term view, historical view, starting from 1950 to nowadays, the evolution of global steel demand in the major regions, China, EU 15, US, Japan. That's kind of the proxy for developed part of the world and the rest of the world. And we can broadly divide this history of 70-80 years into 3 periods. The first period, the post-Second World War, the reconstruction of Europe and Japan. That was a strong global steel demand growth era. Then in the middle, the 70s and 80s, low trend growth era with, lots of crisis, economic restructuring efforts, and also steel industry restructuring efforts, particularly in Europe and North America. And the last part, the China boom. So again, in the first part, reconstruction of two global superpowers, Europe and Japan, and in the last part, reconstruction of another superpower, China, which resulted in a very strong growth period for global steel demand. So the main message I'd like to pass is that strong growth eras for global steel demand are those eras when a super power of world is constructed. Its infrastructure is constructed, its building stock is constructed, its manufacturing base is constructed. And we know that China has, more or less constructed its economy. So going forward, our expectation, the World Steel Association view is that we should expect to see another low trend growth for global steel demand like 70s and 80s. So let me explain why we believe in that way. First of all, for China, we believe that the peak steel demand for the country is behind us. That was 2020, and we should expect to see Chinese steel demand continuing to decline in the medium term because, as I mentioned, the country followed a particular economic development model, which is very investment intensive, but that does not bring good quality growth anymore. That's why the country is trying to move towards a different economic development model, but turning around the ship as big as China is not easy. That is going to take time. But nevertheless, the medium-term direction is declining for steel demand in China. Okay, China's steel demand will probably decline, but in the rest of the world, there are still many big pockets where steel demand will show strong growth. India on top. And on this slide, this table shows some fundamental indicators for India, Mexico, Vietnam. So in basically most of the rest of developing world, that is developing world excluding China, we continue to see very strong growth potential. However, these are starting from quite low levels. That's why they won't be enough to result in another strong growth era while steel demand in China is declining. And an interesting note, still in 2/3 of the global population, or in countries which represent 2/3 of global population, steel intensity is still less than 100 kilograms, another indication of strong growth potential. But as I said, that won't be enough to bring another strong steel demand growth era. Well, we expect low trend growth, but we don't expect the steel demand to collapse or show big sustained drops. And the main reason is that we believe we should see strong infrastructure investment activity in the medium term. And as you know, infrastructure is the highest steel intensity part of the economic systems. Well, why we believe so? Because first of all, in some major economies, infrastructure has been underinvested for 3-4 decades, so that has to change. All major economies have announced major focus on infrastructure for several reasons to boost their economies, but also they have this ambition to become the leader in the new economies, in the new sectors, so that cannot be achieved without infrastructure investments. Climate change, we all know this requires massive investments in our infrastructure systems. Shifting global geopolitical landscape, the others, even aging of societies require some investment in infrastructure. So we believe infrastructure investments will continue to support global steel demand in the medium term. Circularity, the focus of this conference. Yes, we are seeing circularity concepts and applications growing, but from a very, very low level. Hence, it is rather unclear to quantify what the impact will be. Nevertheless, this is coming from IEA's Iron and Steel Industry Roadmap, a great work published in 2020. And they try to quantify what the impact from circularity could be. This is a lot of information, but I would like to draw your attention only to this green part, which suggests that as construction sector becomes more circular, with longer lifetime buildings, longer lifetime infrastructure, and with leaner designs that use less material, construction sector can decrease its steel demand about 200 million tons when compared with the business as usual, that is continuation with the linear model case. 200 million tons is quite big. It's like 1/10 of the global steel demand nowadays. So circularity can have a big impact, but okay, there is big uncertainty surrounding this topic. Intermaterial competition, we saw during the impressive presentations today. In automotive, we are in fierce competition with aluminum, with plastics. But okay, let's look at steel applications. So the typical characteristics of steel applications, they are high volume, they require high performance materials, and they require low cost materials. And in all these three criteria, steel is the material of, or let me put it this way, steel is the material that usually meets all of these three criteria quite satisfactorily. And when you look at the competitors, they do have quite strong limitations, at least in one of these criteria. And we don't expect to see a change in this, really. Okay, in some laboratory, in some part of the world, there can be a new discovery, a new material can be discovered, that's fine. But okay, within the current scene of competition, we don't expect to see a major change over the next 2 or 3 decades. Moreover, well, there is actually one change we expect to see, as our friend from Volkswagen explained. Now we need to incorporate the environmental performance of materials in our calculations and designs. And when we look at the environmental footprint of steel in many applications, it turns out to be the better one. And we believe that with the sensible decarbonization performance, steel sector or steel as a material can even improve its competitive position in environmental footprint vis-a-vis its competing materials. So here also we are relatively optimistic about steel. So all in all, nowadays there are many roadmaps, many studies, many projections for global steel demand. We believe that taking the uncertainty into account, anywhere between 2 billion tons to 2.5 billion tons. So 2 billion tons is a little higher than the current global steel demand level, up to 2.5 billion tons. Well, to me as an analyst working in this industry for some time, they are all reasonable. But if I see a projection which is below or above these levels, then okay, I can question a little bit. And what does this range represent? 2 to 2.5 billion tons. It represents, for 2050, it represents a low trend steel demand growth, about 1% per annum. Okay, we expect low trend growth, but that's for global steel demand. In many segments, we are quite optimistic. In developing economies other than China, we should expect to see continued strong growth. Electrical steel segment, infrastructure segment, energy applications, and finally low carbon steel should be segments where we see strong growth going forward. And with that, let me move on to what we should expect to see in terms of the evolution of global steel production structure. Christoph, do I have enough time? I hope I'm not really exceeding the time, but okay. About 6-7 minutes. Okay, thank you. So yes, global steel production structure is expected to go through a dramatic change, but that's not the first time that's going to happen. This chart shows the share of BOFs in global crude steel production since the year 1980. It's not that long time ago. So you can see from 1980 to mid-1990s, the share of BOFs declined by 15 percentage points. That is, in 15 years, share of BOFs declined by 15 percentage points. That trend could have continued, but China came in the picture, and the massive buildup of BOFs in the country reversed the trend and led to an increase in the share of BOFs. So yes, this can happen, and this can happen rather quickly. But in different ways and at different paces in different parts of the world. Again, when we look at the history, this time we look at the share of EAFs in a country or region's total global crude steel production. On the top we have North America, the orange one is EU, and red one is Japan. In 1980 they were at a very, very similar level, at around 20 to 30% of their production work was coming from EAFs. So they all started from a very similar level, and they ended up at very, very different levels. NAFTA now standing at 70% share of EAFs, and EU standing about 40% it should be, and Japan standing less than 30%, 20-25%. So this just shows that local characteristics, local conditions play a very big role. And that's why also for the future evolution of steel-making structure, we should expect them to evolve in different ways, again reflecting the local conditions such as energy availability, such as raw materials availability, scrap availability, even mindset plays, or some other business characteristics play a big role in this evolution. Okay, decarbonization requirement will be the main driver of change in global steelmaking structure. We've seen these charts a lot. These are coming from IEA's global IEA's iron and steel industry roadmap. Maybe I should start from the one on the right-hand side, which shows the steel industry emissions. We are at around 3.8 billion tons of carbon dioxide equivalent emissions, and that needs to go down to about 1.6, 1.7, and that's a projection which is in line with the Paris Agreement, so keeping the global warming below 1.5 degrees. Well, if the 2050 production level is at around 2 billion tons, so let's say 1.8 billion ton total emissions would suggest an emissions intensity of 0.9 tons per ton of steel produced. But if it is 2.5 billion tons, then it's like 0.7, 0.8. So do you know what I mean? So demand is going to play a critical role in this. So yeah, in order to be aligned with the Paris Agreement, we need to cut down our emissions by about 60%, or if the demand is higher, by about 70% or even more. So that's the challenge we are faced with. But I'd like to connect this with another issue, the energy. There were a lot of points on energy. So it's like we are looking at the energy supply and energy industry in some angles, looking at us to bring the demand to some kind of threshold level so that they can, they can reach the kind of scale. But yes, steel is playing a central role. I haven't added those information on this slide, but I think steel industry globally accounts for around 7-8% of global electricity use and about 3-4% of global natural gas use. So we are big. We account for 1/6 of global coal use. So yes, steel industry, energy industry and hydrogen players are indeed looking at us. Nuclear industry is looking at us. I think Alexander mentioned, the three main levers of decarbonization. So I won't go into details, but mainly efficiency. There is a lot we can do with the current technology or currently available technologies, currently available processes, just by looking at the benchmark technologies or adopting benchmark technologies, benchmark processes. We can achieve a lot. And I sometimes feel the discussion or the focus on breakthrough technologies is a bit crowding out this efficiency potential. But okay, that's another discussion. Increased scrap availability, I will say a few more words on another slide, but these won't be enough. We need to develop and deploy. Okay, so I need to be quick. Breakthrough technologies at a great speed. Scrap availability, we expect it to increase. I think it's obsolete scrap availability by 500 million tons till 2050, and that will be a great help to our decarbonization challenge. Yes, steel industry or steel making structure will show a great transformation, but there are challenges. Moving towards hydrogen steel making are faced with great challenges, development and optimization constraints, financial constraints, and it's not only us who need money to decarbonize, it's basically all sectors. Construction and engineering constraints. So do technology providers have enough capacity to build this kind of DRI making capacity, for example? Labor and talent constraints, energy constraints, raw material constraints. We've heard a lot on these already. And blast furnaces, yes, it seems that we'll need a certain blast furnace capacity remaining for a long time, so blast furnaces need to be decarbonized. the industry is also working, the technology providers are also working on this front, and I am kind of excited to see some promising developments. So in interest of time, I'll just skip. One good news, World Steel Dynamics recently released the Global Steel Industry Decarbonization Report, and that's the projections there for 2030 for the global steel industry are pretty much, you know, in line with the IEA's Iron and Steel Industry Roadmap. That is the Paris Agreement aligned projection. Okay, maybe for different reasons, but I think it's good news. By 2030, we should know much more about our technology alternatives, much more about how the steel value chain is adapting, much more about what kind of green energy availability is out there, so and whether we can access that, so on and so forth. So if we can, you know, remain in the track by 2030, I think that's very optimistic, very good news. To conclude, there will be low trend, still demand growth, but still many opportunities to grow. I believe a sensible decarbonization pathway is possible for most of the steel industry. And these roadmaps, these plans should involve all alternatives, really. So we shouldn't really exclude, at least at this point, some alternatives. I think we should continue to work all decarbonization options. And yeah, this is as I've started with, so this is a great challenge. So we cannot solve this problem alone. We need closer communication, first of all, as the steel value chain with steel users like automotive, with our raw material suppliers, with technology providers. And we cannot just talk, really, or we cannot just write reports. We should also think about, really, how we can work more closely. World Steel Association, my organization, is also you know, we're organizing similar events, so please also do join us, different parts of the steel value chain representatives, so that we can really accelerate this communication, make it a bit more intensive, and hopefully speed up the decarbonization, the performance of the whole value chain. So let me conclude here. Thank you very much for your attention.
Thank you very much, Baris, for your worldview, how steel industry can achieve a sustainable, resilient and flexible future. Maybe just we have time for one question. Maybe you just select one of the questions you would like to answer. Please take the mic.
Okay, the top one. Thank you, Christoph. Do you see circularity already happening in practice? Yes, this is happening. If we look at construction, for example, which is kind of the more difficult sector, we already see a great deal of data availability. We already see digitalization playing a big role in this. We already see different designs are being considered, and the leaner ones, that is those that use less material, those that result in lower embedded emissions, can be selected. So kind of the tools are developing, the approaches are developing, but when we look at the applications, it's still limited. So for example, in the developing part of the world, it's not really there yet. In the developed part, it's still a kind of a niche. It represents a niche part of the whole sector. But yes, in terms of development, we see very intensive action, but in terms of application, it's still at a very low level.
Okay, thanks again, Baris. Yep.